Sound check is clearly working. Rehearsal came in at 9 minutes and 30 seconds, so let's see how I do. Friends and colleagues, okay, firstly, please note that this paper is the product of my private research and in no way represents the official position of the Abu Dhabi Department of Urban Planning and Municipalities. The Walleye Creek design charrette, you see the outcome there, was led by Paul Moraine, was held 24 years ago. It was only the third charrette in Australia, so it was new. It certainly reduced the plan preparation time, like most charrette procedures, by about half, from 24 months to 12 months, so that was a major advance. But otherwise, everything in there was traditional: pens, papers, early use of computers, etc. The Jindi charrette, led by Andres Duaney, was some 8 years later. It introduced me to the biggest innovation in urban planning technique since the charrette. That's the form-based code, regulated by the relative position on a rural-urban transect. So it's a form-based code, and the regulating principle is its position along the rural to urban transect. I was both amazed at its power and beauty, and also very concerned at how, as the Executive Director for Statutory Planning for Western Australia, I was going to get it implemented when it was contrary to all of our rules. But we managed that, so I was in the right position to do it, I guess. I'll explain the diagram in detail later using the latest version, but please note that the community units are there. And clustered land development, technical term for things like villages and hamlets, okay? Typically consists of some T2, some T3 and some T4, okay? The transect does not tell you they have to be in that order. The transect tells you that that sort of thing is composed of those sort of elements, okay? So it's a palette, it's not a prescription. And just remember the Inchi, am I saying that right? The Inchi City presentation at the awards this morning. Okay, one of the slides that came up, they stressed the importance of stream, farm, house and hill. That's a transect. Okay, simple as that. Once you know it's a transect, bang, a whole bunch of professional knowledge surges into your mind, and you know of similar positions and etc. etc. But is a smart code fit for purpose in a world where 3 billion people need cities in the next 30 years? I spoke about RAM2, rapid, massive, third world urbanisation at the Rotterdam ISOCARP in 2015. At CNU, Congress of New Urbanism in Savannah 4 months ago, internationally acclaimed planner and author Peter Calthorpe, that's the author of Transit-Oriented Development, that's how important this guy is, joined the chorus for calling for immediate action on this problem. It translates into building 6 cities of 1 million people per month for 40 years. 6 cities of 1 million people per month for 40 years. Okay? And we have to do that within about 20 because we've got to give the architects and the engineers about 20 years to build these things. Okay? So it's one of those problems where we should have started 30 years ago. We haven't, so we've got to get on with it. It's an existential threat that requires action. Oh, so that's where the cities need to go. Okay? Where we are, yes, we've got growth, but nothing like the growth that they needed there. It needs action, and we know why. We know about the migrant crisis and people swimming the Mediterranean and stuff like that. It needs action. Some action can happen at government level. Most of us are working at the micro level, and technology is getting in there as well. Google's Sidewalk Labs are trying to prepare plans digitally for a new project in Toronto. And in England, Professor Michael Batty, if you've read his book, The New Science of Cities. Has anyone read his book? Okay, you're a masochist too. Yes, I got through it, but it was hard. He's proposing a completely different method to me, you'll be pleased to know. I don't think those methods will succeed because they're missing a vital ingredient, and that's the transect. I'll get to the transect plan in detail in a minute, okay? But the transect needs to go from the water's shed to the water's edge, like lesson 1 in physical geography when I was a student, okay? If you're talking about a regional transect, it's got to go from the watershed to the water's edge. The only time it doesn't is when it's a valley transect and you're going from watershed to watershed. but the water's edge is in the middle there. Now when Hazel Borries at Placemakers sent me this, it was like a light bulb going off in my head. I added that, so you've got the transect at the top, and then you've got the bad stuff at the bottom. And we've been working many times, many projects, trying to work out how to put the bad stuff in, because there's some bad stuff existing. And how do you fit it in with the transect, which is trying to do good stuff. And she arranged it vertically. But in the natural zone, I just put something bad, okay, an extractive industry, and it started to make sense. And hopefully you'll follow the logic in a second. Because what I saw was that. 118 elements in 18 columns and 7 rows. One single numbering system, really complicated, integers from 1 to 118. That's all it takes to understand every element in the universe and every chemical reaction that occurs. Now I'm taking you back to high school science, and clearly you weren't good at high school chemistry because you became town planners like me. But over there we've got the alkaline metals, then we've got the metals, and then we've got the, what were they called, semi-metals or something, and then the non-metals and the noble gases and the unstable radioactive elements there. And the relationships work that way and that way, which is why it's called the periodic table. And you remember that some elements replace some elements, it's blah, blah, blah. Okay, let's get on with it. The smart code. This is where I try and explain the transect in 1 minute and 30 seconds, okay? We have across the top the transect. Then we have a planned view of each of those elements. Now it's a prototypical transect. My American colleagues call it a normative one. I don't know why. They don't understand the word normative. It's prototypical. It's not an actual transect because clearly in that zone and that zone, they might be kilometers long. It only shows one street section, the typical street section for that transect element, in section and in plan. And in the plan view, you have a notional street that goes from one end to the other. Okay. It deserves deep study. I refer you to the Centre for Applied Transect Studies, that's CATS, Centre for Applied Transect Studies. Go to their website, lots of resources. It's tuned to the US legal context, but any trained planner will be able to apply it to their own area. But it only describes half the transect. I'm going to summarise it like that because I need lots of screen space. Okay, so just keep the diagram in your head and go to the numbering system. It only does watershed to centre. And special districts is left to cover centre to water's edge. That's a study from Palomo. Now I'm really summarising things. You need to go to the paper to read the Palomo case study. Okay? But all of those things come out of special districts or some form of park. And clearly we should be able to categorise them. Here's a plan by, that's Placemakers, yes. Okay? And I'll just blow up the key for you. So you can see they've got a Special District 3, Special District 4, Special District 5. Okay, they're subcategorising special districts because they're trying to cram everything into special districts because it won't fit into the rest. Great plan, but the knowledge is lost. The beauty of the transect is that when you're familiar with it, as professionals, we can say T3 this, T4 that, blah, 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 this, and so on and so forth. Okay, your watch is way fast. Okay. Now, can you spot the difference between those? Of course you can. Unless, of course, they're all designed by a modernist architect and they look the same. But normally, they all look different. So they are easy to categorise. So I've categorised them. Done. T7, T8, T9, T10 and T11. And that's very important from my friend Hazel Borries. Just because they're not residential and commercial doesn't mean they can't be walkable. They should be walkable. So now we've got a full transect, watershed to water's edge. And that's it like that. Now we've got the community units and special districts becomes a community unit. Clustered land development, traditional neighbourhood development, regional centre development, and special districts is special to purpose. And we can categorise those according to science, density, building height, blah, blah, blah. They're my calls at this stage. Investigation might prove those calls wrong. Let's look at that in detail. Because we know within suburban we get different gradings of density. Okay? So now we're starting to see how it's periodic. One of the things that happens in urbanism, in towns, is, we need a numbering system. T11, T12, T31, T32, blah, blah, blah. We get succession happening. We have initial, succession, and climax as a place densifies, but without changing use particularly. Or we have succession, initial, succession, climax, where it's changing density and changing use, becoming more diverse. Different things happen, but we now have a way to explain it and to compare it place to place. Now we fill it out with all of the good land uses. Now they're the temporary and aberrant development, often called sprawl, but some politicians for some reason think sprawl is good, so I don't use the term sprawl. Okay? Temporary and aberrant, they will not last. We're seeing them not last right now in our lifetimes. Some of the people here have actually lived through them being created and now falling over, so they don't last a lifetime. Et voila, the full table. Now, let's explore some of the relationships that are in there. This isn't in the paper. I'm 3 slides from the end. But you can start to see just simple density, people to dwelling units. Hey, by the way, we shouldn't talk density outside of professional discussion. Okay, someone mentioned the word density in talking to the public. Never use the word density with the public. Even if they use it, divert the discussion. Okay, height and density. Bang, they're straight line relationships. I don't know how many of us, I've spent many times in a particular study doing an architectural detail of a building to work out how many flats I could fit in a certain plot size, blah, 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 okay? It's a straight line relationship, for heaven's sake. We don't even need to do the study. And we have to do this stuff fast because we've got to build cities for 3 billion people in 30 years. Other things, slightly more complicated curves, but they're not curves that aren't able to be used. So I can develop algorithms, and I've got the algorithms for about half of the periodic table worked out already. I don't necessarily have them worked out with the correct constants, because I need to do some testing, but the XY relationships are there. So here's an example from the, I forget what the Boston MAPC stands for, it wasn't mine. Came from a friend of mine, and I better give it the correct credit. Metropolitan Area Planning Council in Boston, okay, and it came from Matt Lambert. And it's in text, okay? They've done all the analysis, people per acre, blah, 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 it's in text, but really hard to understand. Drop it onto the periodic table, and bang. And not only that, it immediately discloses Peter Newman's 3 cities within a city. You've got suburban and trolley and car happening there on different layers. And so the relationships are immediately apparent. It's that powerful. And the T2, T1, etc., that's for us, that's for professionals. When you do the study, you give the thing names and you talk to the public about names. This is commuter rail, that's trolley suburb. Okay? You don't talk density, that's trolley suburb 2, and that's neighbourhood subway suburb, and that's metro core suburb, and so on. Give them a picture, because the word density means nothing. Density in a village is different to density in a city. And thank you.
Yeah, it's really hard to stop the passionate presentation and to develop a kind of scientific approach to planning. Although I always say it's very contextual and you cannot prescribe. Is your method prescriptive?
No, it's palette.
It is?
It's palette. It's a language that the environmental scientists can use. Environmental scientists can say this is T1, this is T2, this is T3. The urban geographer can say this is T1, this is T2, this is T3. The strategic planner can say T1, T2, T3. The statutory planner can say T1, T2, T3. Okay? So it's a language that we can all use, okay? Just the same as chemistry.
The period table doesn't say that
an acid will always be hydrosulfuric acid or whatever. That's why I'm not a chemist. It just says that's the palette.
Come with a kind of guideline?
That's where we're working to, yes. But the guidelines, like Smart Code, become specific to the place. So Smart Code is specific to North America.
Okay, how do you like the language? Could we talk in T1/4 language next?
It doesn't take long to get, I'll assure you. Okay.
We should have a session actually. Try to talk in T. Yes, the T.
If you remember what I forget the young Chinese lady who did the presentation this morning. Okay, stream, farm, house, hill. Bang. That's a transect. Okay.
Well, it's not new. I mean, I already referred to Patrick Geddes. I think he started this idea.
If I was doing a transect presentation, there'd be a Patrick Geddes slide there.
The natural transect, he called it.
Yes.
I think.
Yes.
1800s. Yes, please.
Thank you very much for your very interesting presentation.
Who are you, please?
Sorry?
If you could introduce yourself.
Hi, my name is Teresa Marat Mendes. I'm from Portugal. And I was really stuck in your presentation. It is very unusual, I agree. But I think it's very challenging as well. It's breaking the barrier in language in different disciplines. And it's quite interesting. But I think there is another component which really attracted me more. It was the diverse scales within the same scale of problematics that you try to reach. And I think that's very potential for planners as a tool, in the sense that it can counteract a vision that is still very present now of everything is just one thing. And you just show that it's possible to read the several dimensions within one of the dimensions in analysis. What I would like to ask is this to be applied just for reading, for analyzing, or how can we use it as a tool to transform, for instance, existing places and improve them? And because I read it more as an analytical perspective. Am I wrong?
I only have 10 minutes.
Oh, sorry.
Maybe you can.
I could have spoken for 2 hours.
Yeah.
Imagine methylation. I get that right. Imagine methylation's tool tuned to pop out not a long verbal report, but the transect diagram. Okay, it's just a bunch of maths, right? The computer can do all of that. So instead of producing a verbal report, he produces a picture of the optimum transect elements that say 80 by 80 grid or something like that, because we can't do urban design with this. Okay, all you do is you say to the urban designer, you have this area, and this is the 3 main elements we want you to see in, and this is the number of people for this particular element. You can't do the urban design with it. It's a planning tool. There is a regional component to it. Thank you for pointing out about the scales. There's a regional component as well, which is in Smart Code. I don't really like the way it works, but it's in there, and the teams over in America do use it. But it's for further investigation as far as I'm concerned. But yeah, I certainly commend Smart Code to you. And the people look at the transect and sometimes think, oh, well, I have to do this and this and this and this. No, that little triangle above that said community clustered land development, or meaning village or something like that, traditional neighbourhood development, or if there's transit-oriented development, is a community unit, a neighbourhood typically, containing those 3 elements in some mix. That's the urban design bit. That's still a skill we have to do by hand. Okay. Yes, Jonathan? Yeah.
I'll go ahead. Jonathan, and I'm from Switzerland, and actually I used to work in the same emirate as Stefan, but we never met in this conference, so great to meet you.
We're in the right time at the right place.
We're in the right time, right place. I'm really intrigued, and I really appreciate your presentation, and I'm sure we'll have many more conversations about it. You've done something which I always thought was a problem with the transect model, which is you've tried to, it's very limited in its scope, and you really tried to expand it beyond its original simplicity. But then I think about the periodic table, and it's actually about singular elements, right, which are unique in the world. And I question whether you're actually able to include all the variations of, let's say, typologies. And there's no, some of those typologies are maybe things we don't want in the built environment, such as sprawl. So I'm just wondering if you've given that any thought, sort of the values placed on these, whether there may be types of development which are positive, types of development which are negative. Maybe there's sort of a nuclear aspect to some of the
Okay,
elements that
okay.
you're looking at.
Yeah,
I would like to combine it with the last question. Who raised the
It's
hand?
not mine, but it's very different, so maybe
Yeah.
I'll ask.
No, please, and maybe you can combine for time
Okay.
reasons.
Yeah, sorry.
Please,
Right.
yes.
Yes, so thank you very much for pointing out the issue of urbanization in the global south and Africa and Asia in particular. It is an issue. Now I was compelled by one point where you showed the direct correlation between densities and height. So I'm based in India, and there are a number now of prominent architects who actually work on the concept of what they call high density low rise. And that has a number of advantages, and one of them is livability, because the question is, certainly cities are growing, but what kind of cities do we want? Do we want livable cities, or do we want concrete jungles? And in that respect, maybe if densities are going to be very high, maybe governments need to think for alternatives, maybe spread out economic opportunities so that everything doesn't come on a single spot. So have you, maybe if you could comment a little
Okay,
bit.
I'll do August first. It may be that the density population curve in India is different to the one in North America, or they're different to the one in Australia. Okay, I'm still working on the algorithms here, but certainly what we're talking about here is going to have to be localized in every particular case. For example, in the Transect diagram, the two-story houses have got pitched roofs. Okay, well in the UAE, no, when I draw it, will have flat roofs. Okay, just a simple example. So that's got to be localized. To get to John's question, just quickly, okay. T31, T32, T33, and the community uses that fit with them, that's all good. T3 minus type B, T3 minus type C, they're bad. They will decay. Okay? If you want to fix them, you're trying to fix them so most of it comes up to here. And it may be some of it goes up to there or some of it goes up to there. But that's your relationship. That's suburban that is good, that's suburban that is bad. That's general urban that is good, that's general urban that's bad. It's on the one table. So that means you can classify it in one system. Okay? I've got a color code for this as well, as you would have expected.
Okay. That's it for the two questions.
I think that's covered, and John will grab me over a beer later anyway.
I hope there are many more questions, but I won't allow you to ask them now. Right?
And well, let me go to that last slide, so just in case. There you go. LinkedIn,
All right.
say you were here.
Yeah.
Okay.
Okay, thank you. Don't have to wait.
Thank you very much.